Okay, finishing up 3-3. 4-1 and 4-2. All right, now let's say 4-1 and 4-2. 4-1 is I want to show you how to plug stuff in on the calculator, like decimal order. So substitute, write it out, plug it in on the calculator. So make sure you can use your calculator correctly. There's going to be some calculator work on your test where you actually going to have to be able to punch up the numbers. And if you don't punch things in correctly, because everybody believes their calculator, this is what my calculator said. Well, your calculator is going to give you the answer for what you plugged in. So the calculator is always correct. Did you put the information in correctly? So there's a catch-22 there. You don't know what you are doing with the technology. Technology is not going to answer the question that you meant to ask. It's only going to answer the question that you asked. Okay. And then 4-2, which takes us into the meat of chapter 4. As you can see, we're going to be done by next Tuesday. Review sheet. There's a quiz on Tuesday on chapter 4. There will be no posted quiz prep. The only quiz prep for chapter 4 will happen at the beginning of class at 10 o'clock on Tuesday. I'll go over the potential quiz questions. And then at the end of class on Tuesday, we take the quiz on chapter 4. Okay. There's been more sirens in the last 2 weeks.
They gave the police money.
Oh, really?
Yeah.
Well, is this, so is it sheriff's?
They gave the whole police station.
Did they?
Yeah. To the city of Madera.
I graduated with Sally Orm. You know who Sally Orm is? She's the DA from
Oh,
Madera.
the DA.
Yeah.
So what you're saying is dress.
Yeah, yeah.
Don't mention my name, Sally Orm, in case you. It won't get you any good. I shouldn't have recorded myself. My name is Todd Kandarian. Right here. Before you apply the division algorithm. So this goes for what we're doing right now for long division. It will also go for what we need to finish up with synthetic division. The dividend and the divisor have to be in descending powers of the variable. They have to go from the biggest power to the smallest power. So we have to reorganize it if they're out of order. 17 is out of order. Also, you have to insert placeholders with zero coefficients if we have missing power in the dividend and the divisor. Look at the divisor, 2x squared plus 1. We're missing x to the first. It goes from 2x squared to the constant, 2x squared to x to the 0. We're missing x to the first. So the divisor needs a placeholder. So this one needs a major retrofitting before we can actually do the problem. Okay, we need to demo it and then rebuild it. So whatever. Bad analogy, but that's here we go. Don't try to rewrite it at the same time you're putting it in, as a division problem. Rewrite it first. The biggest power is our x to the third. So looking across, that's the biggest power, so that has to be written first. So 10x to the third, and now we're looking for an x squared. There it is. Make sure you have the sign. It's minus 2x to the second. Now we're looking for x to the first. There's our x to the first. Positive plus 5x. Then this is x to the third, x to the second, x to the first. And the next one would be x to the zero. X to the zero is your constant because there's zero x's. No, because x to the zero equals what? Zero. Yeah, 1. So this would be, let's go this way. I did this earlier today. If it was -1 times x to the 0, and if x to the 0 was a 0, if the rule of exponents said anything to the 0 power was a 0, then this would be -1 times 0, which means there wouldn't be a 1 there. Every time I kind of like set everybody up with that, what is blank to the 0? I get 0. I do. It's like, I know I gave them like 10 rules of exponents. And I really made a big point about like anything to the 0 power except 0 is always a 1. Burn it. Like get it somehow like inside of your eyelid. They do tattoos inside. So when you close your eyes, you see it. Because it's gotta be a 1. Because that'll mess you up. Mess you up. Look at the decreasing powers. X to the third, x to the second, x to the first, x to the 0, which that power is a 1. It's the 7th rule of exponents. Anything to the 0 power is always a 1, as long as that base isn't 0. 0 to the 0 is indeterminate. So everything to the 0 power is a 1. Rules of exponents are going to be huge. Well, -1. Now, if you notice, I'm not going to put it as a parentheses because division problems can also be written as fractions. There's the dividend over the divisor. Now, the divisor has to be written from biggest power to smallest power. So the biggest power is 2x squared. But if you're missing a power, you need a placeholder. Now we go looking for x to the first. We don't have one. So we have to insert a placeholder and x to the first, 0x to the first. Okay. That way everything lines up when we do the division. If it doesn't line up, it's going to be hard to do the correct subtractions. And then the last term is your +1. Rewrite it first. Then set up your long division. The divisor out here is 2x squared plus 0x and then that +1. We're going to divide that into 10x to the third minus 2x squared plus 5x minus 1. Before you freak out because of this problem, and I understand, I look at it going, oh God, but I'll light a candle on the way home, we'll plug in the right. One thing at a time. It's one tiny little piece at a time. First of all, rewriting this. I know you can read, from smallest or from biggest to smallest. Rearrange it. That's one thing. Just focus on that. Rearrange the denominator if you have to. But you're only focusing on that. Make sure you put the denominator, the divisor out here with the dividend underneath. Now it's just one piece at a time. Again, everything is just one piece at a time. All you care about, the only thing you're looking at is this first term, the 2x squared. 2x squared. And you're trying to figure out what times 2x squared is going to make 10x to the third. So you're looking at this. You want 10. What times 2 makes 10? I need to multiply by a 5. 5 times 2 is the only way I'm going to get a 10. So it has to have a 5. Then I want x to the third. I have x to the second. What times x to the second would give me an x to the third? X to the first. Placeholder. Here is your, almost like a little cheat sheet. The first one would be an x to the third, possibly, because you would be here in this column. Well, if I use x to the third, x cubed times x squared is x to the fifth. I don't even have an x to the fifth column. So there would be nothing above the x to the third. The next, move one over. The next possible column would be right above x to the second. If I multiply by an x to the second, I get x to the fourth. I don't want it. I don't even have an x to the fourth column. So there's not going to be anything here. There's nothing here. So you move over one, and it would have to be an x to the first, maybe. X to the first times x to the second is x to the third. So it's going to start here. 5x. Now, look at the good news. You look at this question and you're going, yeah, right. It starts here at the x to the first. That means there's only one place left to go. This only has 2 terms, the quotient, because you're not going to go left, you're only going to go here. And then a remainder, if there's a remainder. So it's not as ugly as you think. Just what I told my wife. So 5x now times the whole divisor. This is where you have to, that's why the placeholder is here. That 5x times the whole thing. 2x squared plus 0x plus 1. Because it has to distribute. And we get 5 times 2 is 10. X times x squared is x to the third. 5x times 0x. 5 times 0 is 0. X times x is x squared. You need that because, again, it's a placeholder. It's a placeholder. You'll see in a second. And then 5x times 1 is 5x. So when I go to subtract, get x to the third plus 0x squared plus 5x. That way I have something lined up with x to the third, something lined up with x to the second, something lined up with x to the first. That's why that 0 has to be there. Subtract. When we subtract, it's a parentheses minus the whole thing, so we distribute the negative. So you're just subtracting each individual term. This better cancel out. 10x to the third minus 10x to the third is 0. They cancel out. Negative 2x squared minus 0x squared is negative 2x to the second. Negative 2x squared minus 0 is still negative 2x squared.
So it doesn't, so the x squared wouldn't cancel out.
They never do when we add or subtract. 5 apples minus 2 apples is 3 apples. They don't cancel out. And since I do this, so that is negative 2x squared. Right here, Positive 5x minus 5x is 0x. I still want to have a 0 there because it's a placeholder. Because I still have 2x squared plus 0x, and then I have a minus 1. I have one place left to go. The only possible term for my quotient would be here in the constants. So we do it again. We have 2x squared. And we want negative 2x squared. 2x squared, 2x squared. The only thing I need to change is I want negative 2x squared. So what times 2x squared makes negative 2x squared? Negative 1. A negative 1. So I need to multiply by a negative 1. So my last term here is going to be a negative 1. And it has to be in the constants column. Again, when I say constant, I mean a number, no x, which is my only choice because here's the x in the first, and the next one would just be a number, constant. So now you distribute negative 1 times that, 2x squared plus 0x plus 1. Negative 1 times 2x squared is negative 2x squared. Negative 1 times 0x is still just, whether you put plus or minus, it doesn't matter. It's still going to be 0x. And negative 1 times positive 1 is going to be negative 1. Now, if you don't want to do this work up here, if you can figure it out, what times 2x squared is negative 2x squared? What times 2x squared is 10x to the third? And you can figure those out without doing this stuff over here. That's fine. If you can do the distribution without writing it over here, I'm fine with that. Negative 1 times this one, negative 1 times the next one, negative 1 times this one. If you can do that, I'm fine with it. You don't have to show the side work. For those of you that struggle and want to make sure you get it right, do it on the side. But remember, you want to keep it all in that box, so be really organized how you do it. Now we subtract. Subtract each one. And every time here, we're going to be subtracting a negative. Negative 2x squared minus negative 2x squared. These two better make a 0. Negative 2x squared plus 2x squared cancel out. That's a 0. 0x plus 0x, and that's a 0. It's all 0. Negative 1 plus 1. Well, that's a 0 as well. Which means there's no remainder, which means 2x squared plus 1 goes into 10x cubed minus 2x squared plus 5x minus 1 even. It goes in 5x minus 1 time. That's all. But it all relies on getting it ready for the long division. Rearranging the dividend, putting it in the correct order, adding that placeholder in the divisor. And then one thing at a time. And realizing I'm dividing by x squared, I want x to the third. My starting point is here at x to the first. It becomes a lot less menacing when you look at it from that perspective. I'm not starting, I don't have to have 4 terms right here. X times x squared, x to the third. I only have 2 terms. Maybe a remainder if there's something left over. Okay, here comes the second technique. On your test, you will have to do one. Directions will say long division. So you have to be able to do, I think it's 2 problems like this. Then you're gonna have 2 problems where you have to use synthetic division. We did this question and the correct with long division. I think probably took about 15 minutes, maybe. It's gonna take about that long to work it through with synthetic division because I'm gonna write down all the steps, 1 step at a time, so I can show you. But when you use synthetic division, it can change a 15-minute problem down to a minute, 2-minute problem. But synthetic division only works under special circumstances. So second part, 3.3. I think the better we call it a nice shortcut. Shortcut's like, well, why don't you just teach us a shortcut? Because it doesn't always apply. There's a nice shortcut for long division of polynomials when dividing by division of the form. It only works if you're dividing by something that looks like this. It has to be a binomial, 2 terms. So I could not use it on this because that has a placeholder. It would have been a trinomial, 3 terms. It has to be an x to the first. I couldn't use it on this because this is an x squared. I cannot use synthetic division to do this question. It has to be 1 times x to the first. It can't even be a 2x. It has to be a 1 times x to the first. So it has to look like 1 times an x to the first. Now, if it is a 2x, we have some extra work to do. We would have to do things that we're not going to do in this at this level. Okay. So this has to be a 1, that has to be next first, and then minus a number. So like x plus 5, x minus 4, x, I don't know, minus 8, x plus 16. It looks like x minus a k. Remember that thing about built-in negatives? What is k right here?
Keep the sign. Right.
What do we know about built-in negatives? That means here k is negative 5. Over here k is positive 4. Over here k is positive 8. Over here k is negative. The negative is built in. The negative is already there. X minus a k. It looks like an x minus k. So how do I get x plus 5? That's because it's x minus, again, x minus k. It's x minus, and then k is a negative 5. That's how you get an x plus 5, because k is a negative 5. That's the only way it turns into a positive 5. So k has to be a negative 5. Just make it the opposite. I know we're dealing with an H thing, but this is not a horizontal. I'm not shifting it all. Yeah, they use a K. I'm sorry. Remember, K came from me. Okay. You okay with that? Okay. Okay. Anyway. Now they gave an example. We're going to do our other example that we did earlier. But this is what it looks like when they try to teach you with the book. They give you an example with ax to the third plus bx plus c plus b by x minus k. And they don't even put everything. So this is their language. All they do is they put a K here, and they do the A, B, C, D, and they tell you those are the coefficients of the dividend. And then they say remain the coefficients of the quotient. So right here you have the coefficients of the quotient, that's the remainder, and it goes right. It looks like they have an arrow with an A, and they have the KA, and then it goes down, over, down, over, down, over. I don't know what that means. Am I supposed to like draw circles and arrows? Vertical pattern. Which way is vertical? Up and down. So vertical pattern, add the term. So there's nothing there. So I'm going to go A plus 0. And then I go diagonal pattern. We're going to multiply by K. So that's why it must be K times A. And then you add. And then you take this and you multiply by K. And then you add. And you multiply by K. And then you add. It only works for divisors like x minus k. So I'm going to write that up. It's at like 10 steps, but I'm going to actually write it out in words. So it explains it, verbally. They give us these nice clean rags. This one works for so many. A little bit of advice, you don't wash this in the washing machine with white t-shirts. Oh, I meant to show her my other class. My wife's out of town right now, so the dogs are sleeping with me, and this is, that's Bubbles. She is asleep. She was snoring. Her eyes were open, tongue was out, and it just creeps me out like nobody's business. Because I'm just like, put it. And this is Slick back here. They have their Pink Floyd t-shirts on. So their eyes are open. I love it when they have the little, they see with the tongue out. It's like, all right. So x to the fourth is 10x squared plus 4x minus 2x, or minus plus 4 minus 2x, all over x plus 3. Synthetic division has the same rules as long division. It has to be rearranged and put in the correct order. And if we're missing a power, you have to put a placeholder. So it's not in the right order. And x to the fourth, we're missing x to the third. So we have to rearrange it and we're missing a power. So like I said earlier, it's best if you rearrange it before you start writing things with it. This is x to the fourth is the first term. We're looking for x to the third, and we don't have one, so that'll be a 0x to the third. And then x squared is negative 10x squared. And then x to the first is over here, minus 2x. And then your plus 4. So rearrange it if you need to replace it. Divided by x plus 3. So that's step 1. Organize. This is for synthetic division. Organize the terms. Decrease in power. And placeholders. If necessary. Maybe it won't be necessary. The next one. Two. Draw the box. Or maybe just make the box. Whatever, draw the box, make the box. Now it's not really a box, it's more like two sides of the box. Like a corner. Yeah, three. Put K in the box. Which means you might want to identify K before you even go. Remember, it's X minus K. X minus K. So right here, what is K? It's a -3. We're looking at +3 down there, so the actual K value is a -3. So we put -3 down here. K goes in the box. Tab 4. Neatly list the coefficients, just the coefficients. Of the dividend. The coefficients are the numbers in front of your variables. How many of those variables do we have? So this is a 1 times x to the 4th. So that's a 1. 0x to the 3rd. So that's a 0. That's a -10x squared. So the next one's a -10. -2 times x. So that's a -2. And that's 4 times x to the 0. So the last one's a 4. And when I say neatly, don't bunch them all together. Don't like make one higher and lower. You're just going to make a list straight across. You don't put any variables there, just the coefficients. No x's at all. You just want the coefficient. What's numbers? Because the divisor is the only way to do this is the divisor has to look like x minus k. It cannot have anything in front. It has to be 1 times x to the 1st. So as long as they have 1 times x to the 1st, we can do this. Now, the divisor has a built-in negative. So whatever you see, k is going to be the opposite sign. So when we see x plus 3, k has to be a -3. If we saw an x minus 8, k would have to be a +8. Because the negative is built in.
You're only allowed to do that if you have x first.
1 times the next one.
One.
And the directions on the test will say, use synthetic division, which means I would give you a problem that you would have to be able to do it already.
So it's almost like synthetic parameters.
Yeah. Conditions. And this is the tough. Make sure you do this one correctly. Draw the line. So you gotta draw a little line, not underneath here, but like little bit of room underneath, right here. Right. All of it. That's it. So we're about to begin. Okay. Well, I was going to write this out and break it down piece by piece. Yeah, it's fun to go. There we go. Because all of that is just a setup. Now the actual division process begins. So again, earlier from 8:30, remember how long it took us to do this long division. The first thing we do, bring down the first coefficient. So you're just going to bring this one, it's going to come straight on down. Right here, and it's going to be a 1. Right, come on down. Multiply that value, whatever you just brought down, with the K. In other words, times what's in the box and add to the next column. So now we take this one, we go diagonally, and we're going to multiply times what's in the box. So it's going to be this 1 times -3. So we get -3. And then we're going to add. In synthetic division, we add. So we go this way. And we're going to go 0 plus -3. And we get -3. Multiply, add. B to the last column. And then we do it again. This number times the box. So this way, this -3 times that -3. -3 times -3 is +9. And then we're going to go straight down and you're going to add. -10 plus 9. -1. We're going to do it again. We're going to go diagonally. And we're going to multiply -1 times that -3. -1 times -3 is +3. And then we're going to go straight down and we're going to add -2 plus 3. +1. And then we go until the last column. This number times the box, 1 times that -3. We get -3. And then we add 4 plus -3 is 1. Now this last column is the remainder. That last number under the line, that's one of the lines there. That last number is going to be our remainder. The number to the left for the remainder. Are the coefficients of the quotient. The answer. Quotient starts 1 degree less than the dividend. No real frightening talk. Just focus on this first one right here, x to the fourth, and that first one right there. We're taking this x to the fourth whatever, and we're dividing by an x to the first whatever. If you take an x to the fourth and you divide by an x to the first, what are you going to get? If I take an x to the fourth and divide by an x, what am I going to get?
Sorry.
X over x.
Okay.
What will we get?
X to the third.
X to the third, because this is a 1, and we get x to the 4 minus 1, we get x to the third. If I take an x to the fourth polynomial and divide by an x to the first polynomial, the answer should start with x to the third. It can't start with a power that's bigger, because I can't multiply by x to the fourth, because I would get an x to the fifth, and I don't have an x to the fifth. I can't start with an x to the fourth in the answer, because x to the fourth times x to the first is x to the fifth. I can't start with x to the third, because x to the third times x is x to the fifth. That means, I'm sorry, I can't start with it. The bottom line is, the answer has to be 1 degree less. It's going to start 1 degree less than the dividend. So if the dividend is x to the fourth, the quotient is going to be x to the third. If the dividend was x to the ninth, the answer would be x to the eighth. Since this was x to the fourth, the answer is going to be 1 times x to the third minus 3 times x squared minus 1 times x plus 1. And then I have plus a remainder of 1 over the divisor of x plus 3. Now, please, you're going to lose points if you put 1 times x to the third, because 1 times x to the third is just x to the third. Minus 3, x to the second. 1 times x will just minus x plus 1. and then plus your remainder over the x plus 3. Which was the answer that we got doing it for 15 minutes at 8:30. What we have down here in the bottom row are the coefficients for the quotient. 1, -3, -1, 1. And the answer is going to be 1 degree less than x to the fourth. So if you can multiply and add, you can do this. But you have to organize it before you start. And you cannot show up on the day of the test and haven't done it on the homework or try it for yourself. Monkey see, monkey do doesn't work. Oh, I watched him do it a couple of times. I'm good. I got this. How do you start this thing again? Staring is not a viable problem-solving method. I haven't seen anybody with telekinesis going to look at it and it's done. Yes.
I have a question about this, like the last part. Like this,
The last right here.
like the column above it. Yeah, that one. I'm just like, so you would just basically like times the quotient that you got from like adding and subtracting, like you would times it with the, I don't know what.
Okay.
Oh,
You're talking about multiply and then add.
no, I'm just talking about like how you get the final answer.
So these are the quotients, or sorry, coefficients. So it's 1 times x to the third. And then -3x to the second, so it's going to be minus 3x squared.
Okay, so you get that because like. The division problem, right? Like,
Well, I got, these are going to be the coefficients of the quotient as if I did it with long division. This is just an algorithm to get the division done differently. And it helps embedded division. So instead of doing it like we did before, we can do it with this method, provided the divisor looks like that. It has to be 1 times x to the third.
I just don't know like how plug in the quotients. Kind of.
To plug in the x's.
Yeah, like how to plug it in. Like you see, like you got the answer, like x squared. Like you basically got the x or cube by like.
So I was taking x to the fourth. So the answer has to start with x to the third, 1 less.
Okay.
So that's how it starts. And these are my numbers in front. And if it's a 1 in front, you don't put 1. So 1 x to the third is just x to the third. If it's minus 1x, then it's just minus x. Because 1 times x is still just x. Here, yeah, you gotta put a 1 because it doesn't have that.
Yeah, that's all I'm thinking.
So let's do 24, 26, and 28.
Confused on how you got to -1 times x.
Well, that's the coefficient. This is x to the third, x to the second, x to the first, so it's -1 times x to the first.
Okay.
It's at least 1, maybe 2, and then the bonus would have 1. So 24, 26. What I didn't like when I did these yesterday, everything was a plus. They're all pluses. So you choose, you have to do all the way to 29. So you choose 27 or 29.
Sorry?
27. Let's see. 27. Minus 2. Now, 29, you're missing x squared, you're missing x to the first. So you would have to put in 0x squared and a 0x to the first. That's placeholder. So we're looking good. It's x minus k. And just before we even begin, what is k right now? -3. So checking the dividend, x to the third, x to the second, x to the first, constant. All the powers are there and it's already organized. So we're ready to go. We're going to draw the box. We're going to put k in the box, -3. We're going to list the coefficients of the dividend, a 5, an 18, a 7, and a -6. We draw that line. We bring down the first coefficient. It's a 5. And then we go. We multiply this 5. And you don't even have to draw the arrow. You know you're going to go diagonal. It's 5 times that -3. We get -15. And then you want to add 18 plus -15 is what? +3. And then you multiply 3 times the -3. I'm not going to draw the arrows because they can get messy. 3 times that -3. So that gives us -9. Signs are going to matter. And then you're going to add. I was going to put plus. 7 plus -9. -2. Then you multiply. -2 times -3. What do we get? 6. +6. +6, and then add. -6 plus 6. And that's the last column, so the remainder is a 0. Multiply that. Like that took what, a minute and a half? Please. Brought down the 5. Well, listed everything. Brought down the 5. 5 times -3, -15. And then it's just 18 minus 15. 18 minus 15 is 3. Positive times negative, better get a negative. 3 times 3, 9, -9. 7 minus 9, -2. Multiply. Negative times the negative, the positive. -2 times -3, we get 6. -6 plus 6 makes a 0. We were dividing x to the third by x to the first. So this is going to start with x to the second. It's 5x to the second plus 3x to the first, and then a -2. You don't have to put, you don't put 0 over x plus 3 because 0 over x plus 3 is just 0. This is just equal to 5x squared plus 3x minus 2.
Almost too easy.
Well, but there's just same process every time. What's different about this than long division? Long division, you have to look at it on what times this makes this. You have to actually think about what times this makes this. Then you have to do the distribution. Then you have to do the subtraction. Here's bring it down, multiply, add, multiply. And so there's no choice, choosing by you. You're not having to think about what times this makes this distribution and then subtract, change signs. There's a lot of moving parts with long division. But the problem is with synthetic division, it doesn't work with all forms. So it's limited. On 26, x to the third, x to the second, x to the first, x to the 0. It's in the right order. And we're not missing any powers. And that is a 1 times x to the first, so that's good to go. Go ahead, what is k right now? It's a -6. Let's clean that up as well. So on 26, first thing, we draw the box. And put k in the box, -6. And then we just list the coefficients. The coefficients are 2, 14, -20, and a 7. Neat, 2, 14, -20, and a 7. Make that line. Bring down that first one. Bring down the 2. Now we're going to multiply. 2 times -6 is -12. And now you're going to add 14 plus -12. Basically, 14 minus 12 is 2. Then you multiply. 2 times -6 again. So we get -12 again. And then you add. What's -20 minus 12? If that's what you borrow $20, then you borrow another $12. -32. So you gotta make sure you do that subtraction or addition, whatever the addition subtraction is. -20 plus -12 is 13. So now you're gonna multiply. So it's that -32 times a -6. -32 times -6 is positive 192. And then you add. 7 plus 192 is 199. It was x to the third, we divided by x. What does the quotient start with? What power?
X to the second.
X to the second, 1 degree less. So it's going to be 2x to the second plus 2x to the first minus 32. And then you have a remainder of 199 over the divisor of x plus 6. And then if that was your test question, it's like, oh, that can't be 199. It is what it is. How can you be sure? Do long division on it. Yeah, you'll get 199 as the remainder. How can you be sure? Take this times x plus 6. If I multiply this together, what should I get? I'll get that. Because if this divided by this is equal to that, then when I multiply these two together, if I multiply them together, I'll get the numerator. That's the way to do this. I'm gonna do it differently than I usually do. I'm gonna take this one times each one. Because of that right there, for no reason. So it's 2x squared times the x plus 6. And then this 2x times the x plus 6 times minus 32 times x plus 6. And then here's why I'm doing it, plus 199 over x plus 6 times that x plus 6. Right here, I have 2x to the third plus 12x squared. Right here, I have 2x squared plus 12x. Right here, I have minus 32x minus 192. And right here, the one x plus 6 is both reduced, and I just have a plus 199. So combine my terms, there's 2x cubed. 12x squared plus 2x squared, that's 14x squared. 2x minus 32x. That's a 12x. 12x minus 32x is negative 20x. Yeah, right. And then negative 192 plus 1, that's plus 7. There it is. If you know you did the synthetic division algorithm correctly, then don't second guess yourself. Yeah, the remainder is 199. Well, or get up and ask. Great class took a test yesterday, and I even put on the board, don't guess, ask. Come on up and ask. I can't tell you if your answer is right or wrong, but I might be able to point you in a better direction. Maybe 2 times 3 is not 5. Things like that. The way it gets up and ask. So everything that x cubed, x squared, x to the first, yep, everybody's there. It's in the right order. What is k? 2. So we draw the box, put k in the box. Everybody's there. So we're just going to write down the coefficients. We have 9, a negative 18, a negative 16, and a 32. Draw the line. And it's go time. Bring down to 9. And then we multiply 9 times 2, we get positive 18. What's negative 18 plus 18? Equals 0. And then 0 times 2 is what? 0. And what's negative 16 plus 0? Negative 16. And then negative 16 times 2. Negative 16 times a 2. What's that? A negative 32. And then 32 plus negative 32. 0. That's the answer. Now you write down the variables. It started x to the third. We divided by x to the first. So the answer starts with x to the second. So it's 9x to the second This would be plus 0x to the first minus 16, and the remainder technically 0 over x minus 2. I'm gonna fit. Yeah. So that right there is not simplified. But that you're asking a great question, because you're actually asking the question that I hope you ask yourself. That's not simplified. We wouldn't write 0x. 0x is 0. 0 over x minus 2, that's a 0. We don't, clean the, all we have left is 9x squared minus 16. That activity. Four point one. Time to press some buttons. Again, you cannot just show up on the day of the test and hope to figure out how to use your calculator. So on this homework and on 4.2, I actually asked you to do the first few questions, which are vocabulary. Because there's a lot of words that you have to know by heart. Or not by heart, but you have to know the concept. So like, this is 4.2, numbers 1 through 6. And what does it all mean? So I know you've done questions like this. True. 1 through 4. Exponential and logarithmic functions are examples of non-algebraic functions, also called blank functions. So the exponential function f of x equals e to the x is called the blank function, and the base e is called the blank base. What type of transformation of the graph of f of x equals 5 to the x is the graph of f of x plus 1? And the formula a equals p times e to the rt power gives a balance a of an account earning what type of interest? Now, the only one there that I know you can be able to do right now should be number 3. Because we did that in chapter 1. Okay. F of x plus 1, x minus 8. You mess with the x coordinate, it's going to shift the graph left or right or up or down. Okay. Sideways, vertical. Which one? If you mess with x. Sideways. Now, x minus h, so if you see a plus 1, are we going left or going right? Opposite sign. X minus h, so h here is a -1, you're going that way. 1 to the left. It takes this graph and moves it 1 that way. Okay. You remember we gave you the graph and you had to do graph in f, it was like 2 times f, no, what did I do? We did like negative f of x plus 1, and you had to like flip it and then move it. or negative f of x, and then you had a plus 3, so you had to flip it and shift it up or whatever. H is k. You gotta be able to find them. But these other ones, where did they find those answers? Oh yeah, I bet you would look up in the reading. You would open up the chapter and right here. There we go. So far, this text has dealt mainly with algebraic functions. Algebraic functions. F of x equals 3x minus 5. F of x is equal to 5x squared plus 3x minus 8. F of x is equal to square root of 4x minus 2. F of x is equal to 3x minus 7 over 2x plus 1. Let's see. That one. For the most part, those 4 different kinds: rational, radical, polynomial, linear. In this chapter, you will study 2 types of non-algebraic functions. Non-algebraic functions, exponential and logarithmic. These functions are examples of transcendental functions. Oh, wait. These are examples of transcendental functions. I think I saw that question. Exponential and logarithmic functions are examples of non-algebraic functions, also called transcendental functions. Okay. Like when you did a history class, you would look at the questions and then just skim the chapter for those answers, right? Maybe. That's what I never read chapter. I went through high school about ever reading it, which is why I don't do it. The next question. The exponential function f of x equals e to the x is called the blank function, and the base e is called the blank base. So we're going to be on the lookout for that. The exponential function with a base a. Shoot, we want e. But we got to read this. The base a is denoted by f of x equals a to the x. So take a look at where we've been. It's x to the second. The base is the x. Exponential functions, the exponent is where x is. So here's where we've been. Here's where we're at. The power is where x is. Before, the base was the x. The base changed. Now the exponent's going to change. That's the difference between the two. 2 different kinds of problems. Okay. There's some rules that you have to abide by. It's an exponential function when it looks like this: f of x equals a to the x power. And make sure you write the base, and the superscript is where the power goes. If you write ax, that's not a to the x, that's a times x. Or if you write where I can't tell, and maybe you can't tell. If you make it too big, you're going to treat it differently. A to the x. The base, this base a, it has to be bigger than 0. What does that mean? It has to be greater than 0.
It can be a negative.
It cannot be a negative. What else?
It can be a 0.
And it can't be 0. In other words, it has to be positive. It can't be negative. It can't be 0. Also, it cannot equal 1. So we skip 1 because if a was a 1, it would look like this: 1 to the x. Then f of 3 would be 1 to the third. That's just 1. If it was F, plug in 4, 1 to the 4, that's just 1. If we go F of 100, so 1 to the 100, that's just 1. But 1 to the power is just always going to be a 1, so that's not very interesting at all. So the base is never a 1, but it could be anything else. A to the x. And we can raise the base. X can be any real number. The exponent could be any real number from negative infinity to infinity. Which means it could be positive, it could be negative, it could be fractions. It could be rational, it could be irrational. We can do 2 to the pi. 2 times itself pi times. Now, you probably aren't going to do that by hand. It'll calculate. Back in the days, even this was even before my time. Use a slide rule. Okay. Estimate it, those things. So there's rules. The base has to be positive and it can equal 1. X can be whatever. You're going to need to remember, or at least find, or at least look up in the announcements. You're going to want to make sure that you have your rules of exponents. All of these are back in play. You're going to want to make sure you have and know many of your perfect squares, cubes, fourths, and fifths. They're going to help, especially with about, through 10. And maybe not 9 to the 5th, but if powers of 10 are nice. Powers of 10, you're putting in another 0. 9 to the 3rd is really good. 2 forever. You want to know your 2s. Your 3s are good. This is only going to a power 5. But I did give you this one. So all of these are in the announcements. They're emailed, they're in the announcements, so know your powers. Or at least know how to punch it up on your calculator. Let's get to this one. Right there. Properties of exponents. Here we are. The natural base E. For many applications, the convenient choice for a base is the irrational number E. E is a number. The number E. Just like pi is a number. Pi 3.14159 goes on forever. Doesn't repeat a pattern, doesn't have a last digit. Irrational number. Cannot be written as an exact fraction. E is the same kind of number. Cannot be written as a fraction. It has no last digit. It doesn't repeat a pattern. It's known as the natural base. It's approximately 2.7182828, and it's what you get if you take 1 plus 1 over x to the x power, and you let x approach infinity. So if I let x get bigger and bigger, 1 plus 1 over a million, that's 100,000. To the millionth power. This gets closer to this number, but then I'll let it get even bigger. Let's go 10 million. And then let's go 100 million. The bigger you go, the closer it approaches that number E. But you keep on going to infinity and you're getting the number E. And that number E occurs everywhere and in all places in our world. When you compound interest continuously, interest is accrued whether you're paying it or earning it using this formula. The amount that it's worth or amount that it's made or the amount that you pay, whatever. The amount that you have is based on the principal that you invest times 1 plus the interest rate, how much you are either paying or earning, divided by n, which is how many times per year it's being compounded, times n, or to the nt power. So if it's compounded quarterly, n is 4. That's happening 4 times every year. And then t in years, how many years is this going to happen? So if you make a $10,000 investment at 8% interest, $10,000 times 1 plus 8% is 0.08, and it's compounded quarterly. So that would be 4 times a year. How much would it be worth in 20 years? So that would be 4 times 20 years would be, so this would be 10,000 times 0.8 divided by 0.4 is 0.2, so 1.02 to the 80th power. So that's 10,000 times 1.02 to the 80th. I didn't, sorry, not that. I didn't do my 10,000. 10,000 times 2. 80. So after 20 years, it's worth $48,754.39. At 4 times a year. But if the interest is compounded continuously, so that means it's happening every day, every hour, every minute of every hour, every second of every hour, and every millisecond of every hour, at every instant, it's always being compounded. So n approaches infinity. Then the formula just goes to the amount it's worth is equal to the principal times e to the interest rate times time, e to the RT. So that's when interest is compounded continuously. So how much is it worth? My $10,000 investment is 10,000 times e to the 0.08 times 20. So that's 10,000 times e. This is going to be 20 times 0.08 is going to be 0.16. 1.6. Just making sure that my brain is working. I didn't even have room. So 10,000. Now where is E? And we'll get to why E is here in a bit. But E is in blue right here. E to the X. There be E. So when I want to raise E to a power, I have to hit second, and then I hit this LN button, and that will turn on that E to the power. So I'm going to go times, hit the power second, and then E will come up. Save. And then here, and there's E to the 1.6, close the parentheses. And I make a little bit more. It's $49,530. Compound continuously instead of $38,000. Okay. So going back to that homework question, the exponential function f of x equals p of x is called the natural exponential function, and p is a natural base. And number four, A equals P times E to the RT is the balance of an account earning what type of interest? Continuous. Or, I'm sorry, interest that is compounded continuously. Interest that is being compounded continuously. Of continuous compounding. And compounding means when are you applying that formula? If it's compounded quarterly, it's being applied 4 times a year. If it's yearly, it's only being compounded once a year. Monthly, 12 times. Okay, daily, 360. But when is the interest formula being applied to your account? So the rest of 4.1 is punching stuff up on the calculator. So that's why the homework is just 1 through 8 all. So you got 5, 6, 7, and 8. So we're looking at 6 and 8. And by the way, here's E. If I want to just see E to the first, with the number E. Second, there's my E to the, plug in the 1, E to the first as a number 2.71828. So there's E. But again, it goes on forever. The calculator doesn't have a screen that goes forever. Okay. If you're asked to just plug in a number, the most important thing you should do is write it out. So on number 6, don't just go straight to the calculator. Write this out. F of x is 1.2 to the x. We want to plug in 1/3. We want f of 1/3. Remember your chapter 1 test. And I said, listen, all you had to do is plug this stuff into the function. So many of you were just trying to go from f of whatever and then try to do the arithmetic. Write it out. Don't, just make the substitution. What does it look like without actually calculating anything? Then do the work. So it becomes 1.2 to the 1/3 power. So now I'm going to punch it up on the calculator. So I know what actually I'm working with. How do I type in a 1/3 power? You don't need parentheses. So yeah, 1.2. Then here's the exponent. Have you guys noticed that I keep pressing this little arrow up button? That's called it's called the hat button, because it's the exponent button. It raises it to the. Now, if I just go 1/3, watch, this is wrong. 1/3. That's wrong. Because what it did was, order of operations, it went 1.2 to the first, and then it divided that answer by 3. So what does it need? It needs to be 1.2 to the, and then it has to be in parentheses if I want to raise the whole thing to the 1/3. Okay. When I actually type it correctly. And no, you can't just go 1.2 to the, and then think you're going to get away with bonus. Like, oh, that's 1/3 is just like 0.33333. I'll just put a few 3s in there. Because somewhere down the line, if you don't put enough of them, it's going to not be the same. Okay. Learn how to type things in correct. And then number 8. That's 8.6 to a negative 3x. And we're going to substitute negative square root 2. So h of negative square root 2 is going to be 8.6 to the negative 3 times negative square root 2. And maybe I can simplify this before I punch it up. What's a negative times a negative? So this is just going to be 8.6 to a positive 3 square root 2. So when I type it in, let's put this. When I type it in, it's going to have to look like 8.6 to the, I'm going to need parentheses, 3, and then square root 2, and then close the whole thing. So look at the parentheses. Parentheses around the whole exponent. 3 times my, here's my square root 2. My square root has a parentheses to close that on. Don't be in a hurry. These are the freebies. These are, hey, all I gotta do is punch this into my calculator and write down the answer. Yeah, but if you don't type it in, take the time to type it in correctly, they're gonna cost you. And the directions, I've already said, round to 3 decimal places. So that is 9,220.217. Now, you might think, that can't be right, that's huge. 8.6 is almost a 9. Square root 2 is about 1.4. This is like 3 times 1.5. 3 times 1.5 would be like a 4.5. So this is like a almost like an 8 point, let's just say 8.6 to a 4.5. If I was going to estimate. You know, just to get your brain a little, am I close? Maybe I didn't punch it in. Well, that's 16,000. So yeah, I think I'm okay. Then 34, 35. Use the calculator to evaluate the function as indicated at the indicated value range. So just like round to the nearest 1,000. That's 3 decimals. So these functions are natural. They're natural exponential. (34) f of x equals e to the negative x. For 34, we want f of the negative 3/4. So write it. E, there's a negative. Negative, and then we're substituting negative 3/4. So we should actually type in e to the what? Positive 3/4. Now, you don't have to press that hat button. Not when you're dealing with E, because again, E, when I type the E button, again, right here, there are 2 logarithm buttons. You have LOG, you have LN. LOG is the common log button. Right above it is a 10 to the x. That common log button is a base 10. That's why 10 to the x is above. This LN is the natural logarithm button. The natural logarithm is a base E. That's why they're one above the other. So these are both base E. We want E to be X, so you have to hit second and then this LN button. Second. LN. So there's my screen. E to the, I don't have to do the half. It opens up parentheses. I want to put in 3/4. Then I close the parentheses. E to the 3/4 is. And then we're supposed to round, so there's thousand, tenths, hundreds, thousands. So that is equal to 2.117. And that's all you're doing. That's all I want. Evaluate the function at that value of that. Number 35. Yeah, that's is 50 times e to the 4x. So we want x to equal 0.02, g of 0.02. So that's 50 to the e to the 4 times 0.02. So if you can simplify that before you plug it in, you should. Otherwise, you could type it in just like that. You just got to be careful. This would be 50 times E. 0.2 is 2 pennies, 2 cents. What is 4 times 2 cents? 8 cents. So this would just be E to the 0.08. If you simplify it. So instead of having to enter in a multiplication problem, which is fine, I can simplify that and just type in this. So 50 times e to the 0.08. To the nearest thousand. And we get 54.164. Make sure you know how to use that calculator. So you should be able to do all 4.1, finish all 3.3. We will start 4.2 and 4.3 and hopefully get a look at 4.4. Who knows? If you miss, make sure you watch the video because there's a really simple way to get through the rest of this logarithm stuff. If you came in and I didn't get you weren't here for roll, then you're going to be absent. And I get you guys to